Okay, in this video we're going to compare two methods of solving some linear PDEs, namely the method of separation of variables and then the method of characteristics. We have dealt with the second method in another video, which you might want to check out. In this video, we're going to compare these two, so focusing mainly on the method of separation of variables. Okay, so on the method of separation of variables, we are going to note that some PDEs can be solved by assuming a solution in the form of a product. Okay, so by assuming a solution of the form, so we have got u, which is a function of x and y. We are going to assume that it is some function m of x only times some function n of y only, such that m times n is not equal to 0. Okay, then m and n are determined by substituting into the PDE. So m and n are determined by substituting into the PDE. Now, so this method is called the method of separation of variables. So we're just going to look at some examples to demonstrate how this method works. Our examples are going to involve linear PDEs with some Cauchy data. So we're going to solve each method using first the method of so in these examples we're going to want to solve for each problem. First we're going to use the method of separation of variables, and then we're going to use the method of characteristics. You might want to check our video on the method of characteristics for solving quasi-linear PDEs if you're not up to speed with this method. So here we're going to be focusing on this one. We're going to work through it quickly because we've already covered it before. So in part A, we've got this PDE with this given initial condition, if you like, and same thing for the second one and third one. Okay, so let's get on with the first one. So in this PDE, we've got ux minus 3uy equal to 0, and then we're given that when y equal to 0, u is equal to 4e to the minus 5x. So in the first approach, we are going to assume that we can write u as m times n. M is a function of x and n is a function of y only. So it means the derivative of u with respect to x is going to be m prime times n, and the derivative of u with respect to y is going to be m times n prime. Then we are going to substitute into the PDE. So substituting gives, so this term is going to be m prime times n minus 3 times the other term is m times n prime, and this is equal to 0. Now at this point, what we are going to do is if we bring this one term to the other side, m times n prime, then we are going to divide by, so this is sort of a standard step with the method of separation of variables. We're going to divide by m times n. Remember, m times n is non-zero, so we can divide by that. So the left hand side is going to be m prime times n divided by mn, and this side is going to be 3m times n prime divided by mn. Then on the left hand side, n is going to cancel out. The right hand side, m is going to cancel out. And so we are going to have m prime over m is equal to, I'm going to bring the 3 down here, and this is going to be n prime over n. Now remember that m is a function of x only, so that means its derivative is a function of x as well. N is a function of y only, so its derivative is a function of y only as well. So what we have here is a function of x on the left hand side and a function of y on the right hand side. Now whenever that happens, it means that our function is a constant. I'm going to just spend a minute or two to make this point here. So if f of x is equal to g of y, then f of x equal to g of y is equal to a constant. So that's the thing we are going to establish before we go on. Okay, how does this work? Okay, it works as follows. So provided that this is true, if we differentiate both sides with respect to x, okay, so differentiate with respect to x, okay, then this is going to be f prime, and then this is going to be 0 because it's a function of y only. Now if f prime is equal to 0, of course it means f is equal to a constant. Well, f is equal to g, so g is going to be a constant as well. Right, so going back to our PDE, which is now an ODE, what this step is saying is that since this is a function of x only, it's a function of y only, then this must be equal to a constant k. So the constant k is called a constant of separation. That means from this we can have two ODEs now. If you take this one, okay, and bring n to the other side, we're going to have n prime minus k times n is equal to 0. And then the other one, we're going to have m prime minus 3km is equal to 0. Remember, this one is an ODE dependent on y. This one is an ODE dependent on x. This second one is linear. The integrating factor is going to be minus 3kx. Again, you can check our video on integrating factors and linear ODEs to get yourself up to speed with this. Multiplying this ODE by this integrating factor, we're going to get m times e to the minus 3kx prime, so that's the derivative, is equal to 0. And then integrating tells us that this is going to be m times e to the minus 3kx is equal to a constant a, and therefore m of x is going to be a times e to the power 3kx, where both a and k are constants. Then similarly, from this ODE here, then n of y is going to be b times e to the power kx. In that case, notice that these ODEs are the same, except that this one has got a 3 there, this one has got a 1. Okay, so we now have m and n, which means we can write u. Remember, u is m times n. So therefore, we're going to have u is equal to ab, so that's the constants. Then we're going to multiply the exponential terms. So we can write this as c e to the k into 3x plus y. Just a typo here. This one is a function of y. Okay, so where c is another constant formed by multiplying nb. So this is our general solution then of u. After that, we're going to apply the Cauchy data. So we are given that when y is equal to 0, u is equal to 4 times e to the power minus 5x. So that means we're going to take this and plug it in here. On this side, we're going to plug in y equal to 0. So we're going to have 4e to the minus 5x is equals to ce to the 3k, we're substituting y equals to 0 to the 3kx. Okay, then comparing these two sides, the coefficient c must be equal to 4, and this must be equal to that. So 3kx must be equal to minus 5x, which means k is going to be equal to minus 5 over 3. And so we can now write our particular solution is going to be 4e to the minus 5/3 3x plus y. So that is going to be the solution of this PDE here satisfying that condition. Right, we're now going to do the same thing, solve the same problem. We are going to now use the method of characteristics. Okay, so this is 4e to the minus 5x. All right, in the method of characteristics, the characteristic equations will be dx over 1 equal to dy over minus 3 equal to du over 0. Like I said, you can check our video on the method of characteristics for solving quasi-linear PDEs if you're not up to speed with this. Just taking this last term here, that last term implies that du is equal to 0, and so u is equal to c1, which is going to be equal to our phi. Then from the first two, we're going to have 3dx plus dy equal to 0. This one is telling us that 3x plus y is equal to c2 is equal to our psi. Now from the our deliberations on these, we said then the general solution is going to be given by phi equals to f of psi, or vice versa, where f is an arbitrary function. So in this case, it means we're going to have u is equals to f of 3x plus y, where f is an arbitrary function. Then we are going to apply the Cauchy data. So when y is equal to 0, u is equal to 4e to the minus 5x. So that means we're going to plug this here. We're going to plug in y is 0 here. So we're going to have f of 3x is equals to 4e to the minus 5x. Then here, if we let xi be 3x, then x is xi over 3. Then this equation is f of xi is 4e to the minus 5 xi over 3. So that gives us the functional form of f here. Okay, so then we can write, so u is going to be 4. Let me just write it like this. So it's going to be the exponential of minus 5/3. Then we've got 3x plus y. Now you're going to notice that this is exactly the same function or solution as the one that we obtained using the method of separation of variables. All right, so that sorts that one out. We're now going to go to part B. In part B, we have got xux plus 2uy is equal to u. Then this time when y is equal to 0, u is 4x cubed. So again, we're going to start with the method of separation of variables. We're going to move a bit quickly this time because we've already set the procedure up in the first example. So from here, ux is m prime n as before, uy is mn prime. Substituting gives the following. So the PDE becomes, so we're going to have xm prime n plus 2mn prime is equal to mn. Okay, then again we are going to divide by m times n. So when we do that, the first term is going to be x m prime n over mn 2 times mn prime is equals to mn over mn. Remember, mn cannot be equal to 0. The first one simplifies to m prime over n. This one is going to be 2 times n prime over n, and this one is equal to 1. Then we're going to take the, so this one is a function of x only, function of y only. This one is a constant, so we can match it with any of these two. So we are going to take the function of x to the right hand side. So this is now entirely a function of n. This is a function of x, so that means this must be equal to a constant. Then separating those variables means that we're going to have n prime minus k over 2n is equal to 0. Solving this one using the approach of integrating factors as shown in the first example is going to give us n equals to aky over ae to the power ky over 2. The second one, which is a function of x, I think is such that it demands us to go through it a bit slower. We're going to do this one more step by step. If we multiply by m here and divide by x, we're going to have m prime plus k minus 1 over x m equal to 0. Then the integrating factor is going to be the exponential of the integral of k minus 1 over x dx. Okay. This is going to be the exponential of ln of x to the power k minus 1. So this is simply going to be x to the power k minus 1. So that's going to be our integrating factor. So if we multiply this ODE by that, then we're going to get d dx of m times x to the power k minus 1 is equal to 0. Integrating this gives us m x to the power k minus 1 is equal to b, where b is a constant. And so m is simply b x to the power k minus 1. And so our u, which is m times n, is going to be c times x to the power k minus 1 e to the power ky over 2, where c is 8 times b. Okay, so this is a function of x and y. Then we're going to bring in the Cauchy data. So this time when y is equal to 0, u is 4x cubed. So we're going to have 4x cubed on the left hand side. On the right hand side, we're going to plug in y equal to 0. Comparing these two sides shows that c is equals to 4. Then in order for this power to be equal to 3, k must be equal to 4 as well. So k is equal to 4. Just 1 second. Okay, there is his minor typo here. Yeah, so from here, from this step here, the function m should be equal to x to the power 1 minus k, because it's k minus 1 on the left hand side. So that means we're going to have 1 minus k here and 1 minus k here. So if 1 minus k is 3, then k is going to be negative 2. So negative 2 here. All right. So that means the particular solution, so u of xy is for x to the power 3 e to the minus y. We're plugging in k is negative 2. We're plugging in k is negative 2 here. It gives us 3, gives us minus y. So that is our final solution. Okay, so let's see if we get the same solution working through this using the method of characteristics. So our problem is x ux plus 2uy is equals to u. The characteristic equations are going to be dx over x equal to dy over 2 equal to du over u. From the first two, we are going to integrate that to get ln x is equal to 1/2 y equal to cy. If I multiply by 2 and bring both to the same side, I'm going to have ln x squared minus y equal to c1, which is going to be our function phi. Then if we do the x and u terms, okay, then we're going to get ln x is equal to ln u, let's say plus ln c2. So this is going to be telling us that u over x is equal to c2, which is going to be our psi. Therefore, the general solution is going to be u over x equal to f of ln x squared minus y, where f is an arbitrary function. Then we're going to bring in the condition that when y is equal to 0, u is 4x cubed. So we're going to plug in 4x cubed in the place of u here, and then we're going to plug in y is equal to 0. Then again we're going to let a new variable xi be ln x squared. So we want to know what this side is going to be in terms of xi. So just notice that this simplifies to 4x squared. So from here, x squared is e to the xi. So that means we have f of xi is 4e to the xi. So that means we have the functional form of that. So therefore we have u over x is equal to 4 exponential of whatsoever we have there. What we have there is ln x squared minus y. So u over x, this is u, 4 exponential of ln x squared is just x squared. Then there's going to be exponential of minus y. Then if we bring the x to the right hand side, we've got 4x cubed e to the minus y, which is exactly the same as the solution we found using the method of separation of variables. You're going to notice that the characteristics method is typically working out shorter in both of these methods. However, if the question says use the method of separation of variables, and then of course you want to use that method. So that's why you want to master both methods. All right, there is a third example here. We are going to give you an opportunity to work through it, and you can pause the video while you're working on it. Then when you press continue, when you press play, then you can compare your solution with what we will have for you. All right, we're now going to scroll down to our solution of part C, using first the method of separation of variables and then the method of characteristics. Okay, so for the method of separation of variables, if we let u be m times n, and if we substitute here, the x derivative is going to be m prime n plus x times the y derivative is going to be mn prime. On the right hand side, we're just going to have mn. Then from this step to this step, if we divide by mn, then on the left hand side, that's what we're going to have. On the right hand side, we're going to have 1. Now, as a function of x only, as a function of y only, but we've got an x here, so we need to take the x and bring it with these terms. So if we take this term to the other side and then bring the x along, then all these now are dependent on x only. These are dependent on y only. So that means this is now equal to a constant, which we say is the constant of separation. So the n equation, which is an ODE, will look like this, and that is its solution. The m ODE will look like this. If we rearrange it further, we can write it like that. Then the integrating factor is going to be the exponential of the integral of this term. So integral of kx is half kx squared. Integral of -1 is minus x. So multiplying the ODE means we can write it like this after multiplying it by the integrating factor. And so the solution is going to be b e to the x minus half kx squared, where b is a constant. Then when we multiply the m and n, then that's going to be our solution for u, where c is a b. Then now we can apply the Cauchy data. So when x is 0, u is 5e to the 8y. So we plug in 5e to the 8y here, and we plug in x is 0 this side. So that tells us that k is 8 and c is 5. So that is our final solution there. Alright, then if we do the same thing using the method of characteristics, the characteristics equations will be dx over 1 equal to dy over x equal to d over u. Integrating between the x and u terms gives us this solution. And then integrating between the x and the y terms gives us this solution, which we can multiply by 2 and rearrange. So got 2y minus x squared equals to a constant. So that means our solution can be written as this equal to a function of that. Then when we apply the Cauchy data, so where there is u, we're going to plug in 5e to the 8y. X is 0 here and here. So it's going to be f of 2y. So if we let xi be 2y, then y is xi over 2. So it means this is going to be xi, and that is going to be 4xi. So that's the functional form of f. So then we can go back and plug it in there. So we're going to have ln u minus x equal to, so it's going to be ln 5e to the 4 times whatever we have here, which is 2y minus x squared. So then if we take exponentials on both sides, so this side is going to be u times e to the minus x, which is that minus x. This side, which is going to undo the ln, so we're just going to get that. And then if we make u the subject of the formula, then we get the same thing as we got before. Alright, thank you for watching. Hopefully this video has been useful to you. Please do subscribe to get notified whenever we post new material.